So this is a talk about the current state of the art of AI, a little bit about the present, a little bit about the past, and a few words about the future. So the outline is very simple. So without further ado, everybody knows who Bloomberg is, but most people know us as a media company. Now, we are much more than that. We are a technology company, and while most people have seen, some of our products, they don't really see us as a contributor to AI. And what most people don't know is that we started investing in artificial intelligence more than 15 years ago. First projects that we had undertaken, first products that we rolled out to clients powered by machine learning and AI date back to around 2008, 2009 timeframe. And this was a very different world back then, right? So this is before ChatGPT, before transformers, before deep learning took over the world, right? This was not, there was no transformers libraries, there was no PyTorch, no TensorFlow, none of this stuff existed, right? So the question is why? And the answer is in many ways encoded by this picture. So this is one way to characterize the growth in amount of machine-readable data that's available to the world, right? So this is the aggregate number of ticks that we ingest. So these are quotes and trades for everything that's actively traded everywhere. So in April of last year, during the tariff volatility, as people have charitably called it, we crossed the threshold of 650 billion ticks per day. So this is the picture that keeps our engineering management up at night, right? This is why we have to keep building data centers. And to give you a point of reference, so this little blip right here, so that's the 2008 financial crisis. All right, so what had been a momentous occasion at the time when it happened is an average Tuesday, a few years later, right? So this is quite an interesting picture, but this is just a one way to characterize the amount of information that our clients have to deal with, right? So when I started the company in 2007, we were already ingesting on the order of 250,000 news stories per day, right? And now that number is routinely over 2.5 million news stories per day, right? So, and this is in 43 different languages coming from over 100,000 different sources. So there is simply no way for humans to take advantage of this information and make use of it without tools, right, enabled by machine learning and AI. So the world, as I had mentioned, had changed dramatically, right? There have been a lot of progress. The pace of change is still accelerating. So one of the things that I do besides my work at Bloomberg, I run a conference called Machine Learning in Finance with Columbia University. And last year, when I was putting this conference on, I had to look through 1,300 abstracts of papers to choose the 8 speakers for the day. Right, so there are literally thousands of machine learning papers published per year just in quantitative finance. Right? It's an overwhelming amount of information. There have been a lot of progress in open weight models. I emphasize weight, not source, because they are none of them are really open source. So people will have heard of things like Llama and MPT, Falcon, which is from this region, DeepSeek models, and so on. There have been a lot of work in new architectures. So people are, for example, proposing new, more computationally efficient variants of these models, as previous speakers have spoken about. New architectures for data other than text, like pixels or multimodal kinds of models, and all of this leads to genuinely new applications. So for example, in finance, people are using these models not limited to text models like ChatGPT, for things like hedging positions, options pricing other kinds of exotic instruments, including fixed income instruments and so on, to do simulations, to do agentic strategy development, and so on. And in fact, there are still new conceptual directions which are introduced continually. So, for example, people may or may not have heard of things like machine learning with physical priors. So this is where you are able to integrate priors in the form of a differential equation, right, into your neural network. And as these models are applied increasingly to mission-critical applications, there is a great deal of focus on things like algorithmic fairness, privacy, explainability, robustness, right, and the overall AI guardrails. This is where we do a lot of work. We publish more than 30 papers per year, and a lot of them are in the area of AI safety and robustness. So there is a lot going on. One way to characterize the progress is this picture. So this was put together by a researcher whose name is Maxime Rabon. So the green dots here are open weight models, and the red ones are proprietary. So this is up to April of 2024, right? And you can ask a lot of questions about this picture, like, for example, what happened there in the middle with ChatGPT? It's not really consistent over time. Right? Then a later version of this picture looks like this. So this is up to July. And the trends are pretty obvious. So I made my own version of this, bringing it up to 2025, right? And the trends have become even more clear, right? So there are a couple of interesting things to note on this chart. So first, you will notice that the performance of the proprietary models and open weight ones are essentially have converged, right? So, which is quite unprecedented, right? So another thing you will notice, so this is a particular data set which is called multimodal lingual understanding, MMOU, and you will notice that it hadn't quite been saturated yet, right? So there is a plateau in terms of performance for many of these models. Another interesting detail here, people will have heard or used ChatGPT 3.5 Turbo, right? That model was already very capable, and it was also enormous, right? It was extraordinarily expensive both to build and to run. It took tens of millions of dollars to train, right? It was something like 175 billion parameters, right? And only a year later or so, right, we have models like Gemma or Llama 3, which are 20 times smaller, right, and are on par or better than GPT 3.5 Turbo. So suffice to say that there is still a lot to learn about how to build these models in an optimal way, right? What the right scaling laws are, how much data do you need to saturate a certain number of parameters, and so on. So this is quite an interesting time, right? And in our world, in our industry, the range of applications, starting with very simple ones, things like search and discoverability in around 2008, 2009, right? And then more complicated things like sentiment analysis and market impact indicators and so on had expanded dramatically to things like machine translation and novelty detection. And then nowadays, our own domain of application for these tools looks something like this, right? So this is basically all of natural language understanding known to man, right? And a lot of other things which don't fit into text, so things like ranking and time series analysis. Suffice to say that we use this technology everywhere, right? The group, which is now called the AI Engineering Group, which I used to run for many years, now is over 450 people, right? So we use this stuff in every part of our business, right, to power many, many products. The complexity in this picture goes up to problems which are still in many ways open research problems, despite what Sam Altman will tell you. Right? So if you were to categorize the use cases in our world into big buckets, you would end up with roughly 4 or 5 different buckets, right? So one is signal construction. So you take unstructured data like text, right? Nowadays it could be anything like credit card receipts or vessel tracking or foot traffic data or anything really, right? And this data goes into a AI or machine learning model, and then numbers come out that you can then use for trading or for risk analysis and for portfolio construction and so on and so forth. So this is the beginning of the investment workflow. This is the idea generation part, effectively, right? This is where you're looking for inputs into trading strategies. Then at the very, very other end of the trading workflow, once you have already decided what positions you want to take, you need to turn that into trades somehow. So that leads to execution-related problems, right? So this is choosing which venue to route your orders to, how to break down large orders into smaller ones for optimal execution, to minimize market perturbation, and so on. Then in the middle between these two, there is an interesting area which is alpha research and strategy development. So this is where you deal with problems like portfolio construction and optimization, but also a lot of other idiosyncratic problems that have to do with actual alpha search and strategy discovery. So this is quite an interesting area to work in because you have to work effectively under cryptographic assumptions. So people who do work in this area, they don't publish and they don't say anything to anyone. So you have to infer a lot of things about what they do by questions that they ask you, right? So it's kind of like Alice and Bob cryptographic protocol sort of thing, except backwards. And then, of course, the generative AI applications, which used to be, as of, for example, a year or a year and a half ago, mainly concerned conversational AI assistants for things like question answering, summarization, and so on, nowadays increasingly are being used to do actually automated strategy development and AI research, right? So where the model or ensemble of models actually takes place of an analyst generating ideas, right? So, and you end up with this kind of loop, right, where you can automatically test these trading ideas, right? So, and then for completeness, I also, of course, mention things like risk, compliance, and fraud. So every insurance company, every credit card company has to do things like counterparty risk and fraud probabilities and so on. This is not new, right? So notice that most of these things have nothing to do with text and nothing to do with generative AI, right? So, AI in that sense is not new, right? We have been using it for a long time, right? And a lot of it has nothing to do with language. Now, but you cannot talk about AI today without talking about LLMs, right? So I thought I would give people an idea of what these things are, right? So there has been a lot of debate about what these models can and cannot do. And the common theme is that they are just stochastic parrots, quote unquote, right? So, well, if they are just stochastic parrots, why are they so powerful, right? Why have they been able to convincingly pass the Turing test, and why can they talk humans into doing increasingly strange things, right? So, and to answer that question, you have to think from first principles about how these models are trained. Because the objectives set during trading shape the intelligence of these models in profound ways, right? So they are trained in multiple steps, and the most expensive and the most unobvious step is the one called pre-training, right? Where we basically get all the text, all of the internet, right? We break it up into words and phrases. We mask some words in that text, and we ask the model to guess the missing word, right? Which is not the end, that's the beginning of how they're trained. But this is a step where these models actually learn most of what they know. Well, consider this as a game. Like if I give you these sentences and I ask you to guess what the missing word is, right? If you look at these examples, you will notice that you actually have to know a lot about the world to be able to answer and to play this game correctly. Right? You need to know names and places of things, right? You need to know a lot about the language to understand things like prepositional attachment and other linguistic phenomena. You learn implicitly things like categorization, like whatever is in the aquarium probably swims in water, right? You learn things like opinions. For example, that movie clearly was not great, right? And if I ask you this question, you actually need to do arithmetic to answer it, right? So this is to show that this objective is deceptively simple, right? It's simple to state, but it is actually profoundly powerful, right? This has been the vehicle behind most of the progress in natural language understanding in AI in the past 20 years, believe it or not, right? Now, there is a lot more to it, right? Fundamentally, these models are different, right, from the previous generations of AI models in very important ways, right? So they are very general. That is to say, a single model is capable of many tasks, right, without potentially problem-specific training, right? So they are very broad, right? They encode, by virtue of the fact that they memorize everything they see, a lot of the knowledge about the world, right? They learn also very complicated extrapolation functions, right, that enable them to be effective at many tasks, right? So they're accessible. So this is a big one, right? Because you are now talking to the thing in human language, not in code. So your grandmother can use it, your child, right? Which brings us to a lot of interesting questions. So the most recent surveys in the United States indicate that more than 75% of school teachers are using ChatGPT to create lesson material for their classes. So I invite people in the audience to estimate how many of your children are using ChatGPT to answer those exact same questions, which begs me to question where the learning is happening. And I have to deal with this as a professor at Columbia, right? Like where the assignments that people used to hand in, which were imperfect but genuine, now look perfect, right? But when I ask people questions in class, nobody says anything. Silence, right? So I have to redesign the entire course, right? One thing that most people don't, underestimate, right, is that you can use these models to translate text into code, right? Which means that these models can serve as a kind of universal language interface. They can be essentially a way to encode executive actions, right? So, and people have already done a lot of interesting stuff with this. For example, being able to control robotic arms by language, right? Or being able to control a drone, giving it language instructions and so on. And they are very adaptable, right? Because you are able to learn new tasks from a few examples, and you furthermore can connect them to tools and data, right? So to give them access to the broader ecosystem of tools. So these are very powerful, but they also have a lot of limitations, right? So they are still in many ways limited when you talk about long horizon reasoning and planning, right? So the longer the sequence of steps that you have to take, the more likely the errors become, and the errors compound, right? So they hallucinate, or better to say, confabulate, right? So everyone has probably encountered these, and this issue is universally misunderstood, right? That's not a bug, that's a feature. Because when you're asking this model to generate code for a problem you have never seen, you're asking it to hallucinate, right? Which means that this issue is never going away, right? Again, despite what Sam Altman will tell you, right? So until we invent new ways of training them, different ways to actually pose the objective, this issue isn't going to disappear. So they are computationally extraordinarily expensive, right? So cost of training of these models is enormous. Even inference cost at scale can be material, right? And because of how expensive they are to train, these models are largely static. Right, so the data set ends at some point in the past. So to give them access to current data, you have to give them access to the internet or to tools or both, right? And that is actually very tricky to get right, right? So the right architecture for that sort of thing is a subject of a great deal of work and current debate, right? And a lot of people are struggling with adoption of these models. So I felt it would be interesting to see, the past, present, and future of AI prognostication, right? So these are some of the choice quotes, right, starting from the birth of AI in the 1950s, right? So, and, back in the 50s, people made a lot of rapid progress very, very quickly, right? So we got first game-playing programs like chess and checkers. We got things like logic theorist and general problem solver. So first genuinely AI applications, right? First neural networks were invented and built back then in 1958 or early 1960s. And people kind of excited by this rapid progress made a lot of statements which in retrospect look premature, let's just say that, right? So, and by the way, Minsky, when he said this, right, was the head of the computer science and AI laboratory at MIT. So he ought to have known better, right? In retrospect, a lot of these problems that we're trying to solve are enormously difficult, right? And we're only now realizing how difficult they are. And now, after a long break, which people call AI winter, right? In the past 20 years, we have also made a lot of rapid progress. And now people are also saying things which I think in retrospect are going to look a little bit suspect, right? Suffice to say that AI, I think, has not materialized as the biggest existential threat that we face today, right? And now people are saying that we might have human-level AI by 2027. Let's just say that my own timelines are a little bit longer than this, right? But you don't actually need strong AI to feel the impact, right? So a lot of institutions are struggling with AI adoption, as the previous speaker had alluded to, right? Because they lack the know-how, they lack skills, data sets. Education, therefore, is crucial. There is tremendous uncertainty driven by this frenetic pace of change. New developments are literally available weekly, right? But there is, as I said, signs of plateau, right? So you need different architectures and different kinds of models to actually make progress on problems which are material to us. There is a lot of hype, right? And this all leads to drastically different regulatory outlook in different regions. And I do a lot of work with regulators, right, around the world. So this is, a very important debate, right, and topical for this conference, right? Because depending on whether you fall on the rule-based prescriptive approach to AI regulation or a principles-based, guidance-based, right, you end up with wildly different outcomes, right, which you can see currently, right, between, for example, the European Union and the United States, right? So now, I originally wrote this slide in 2016, right? And already back then, there were multiple studies that indicated that up to 50% of all employment would be at risk within the next 20 years. And I showed this slide and people laughed at me. Well, they're not laughing anymore, right? You don't need strong human-level AI to feel the impact. You can still affect enormous societal change with quote-unquote weak AI. And the problem, in many ways, is the fact that most of the people at risk are not even aware of it. So in 2016, when I was part of this non-governmental organization called the Shift Commission for Future of Work, right? And we actually studied this question. So we would show videos of self-driving cars to truck drivers in Virginia, right? And people would watch these videos and go, that's really cool. So you're literally showing somebody a machine that's going to take away their job, and they have no cognitive vocabulary to even understand what's happening, right? And this is still the case today, right? So the best case scenario that I estimated was profound uncertainty and upheaval, which is exactly what we're seeing realized. So now, I think today we're only scratching the surface, right? And this is going to sound like science fiction in many ways, but I know literally somebody working on every single thing on this slide, right? So people are using these models for example, climate adaptation, to do biodiversity monitoring by putting drones and cameras in, cloud forests in Borneo, right? Automating some things which are very tedious and dangerous for human beings. So predictive maintenance using sensor data. Autonomous equipment is not new, but now you can automate inspections. So for example, a drone goes over a bridge, right, takes pictures, and now you know where to go and what to fix, right? Completely automated, right? So my friends in the Ministry of AI here in Dubai are using this to lay out infrastructure for things like rail tracks and pipelines and stuff like that. New molecules for preservatives, right? For legal work, right? These models are already superhuman in many ways, right? So I was reviewing paperwork for a private equity deal, and I gave the actual documents to ChatGPT, and I did a better job than my lawyer. Like literally found more things in the document than the person. So, if I were a lawyer, I would be seriously concerned right now. In culture, people are using these models to preserve dead languages, right? It will learn a dead language just as easily as English, right? It doesn't care whether there are any speakers left, right? So give it text, it will understand it. So in science, people have gone to town with simulation, modeling emergent behavior, autonomous agents for research, similarly to what I alluded to about finance, right? And people are working on things like digital doubles, right? I know somebody working on interpreting the language of dolphins, right? And wolves in the Yellowstone Park. We're this close to neural interfaces that actually work, which gives you essentially, mind-to-mind communication, right? And again, my friends here, for example, in Dubai are talking about using AI to mediate treaties, right? They're very ambitious. and very forward-thinking people. So, the next 20 years are going to be wild. I don't think we have seen anything yet, right? So it's going to be a very interesting time to be an AI engineer. So if your children are asking you what to study, that's not a bad place to go, right? If you're interested in more, you can take a picture of this QR code. This will take you to a page where we describe our approach to AI and some of our work on AI. If you have follow-up questions, feel free to get in touch with me. And I don't think we have time for questions, but thank you very much. And it was a pleasure.